The 2014 Pacific hurricane season marked the third consecutive season in which a tropical cyclone was noted in May. The season officially started on May 15 in the East Pacific Ocean and in the Central Pacific on June 1. They will both end on November 30. These dates conventionally delimit the period of each year when most tropical cyclones form in the Pacific Basin. However, the formation of tropical cyclones is possible at any time of the year. Seasonal forecasts. On March 12, 2014, the Servicio Meteorológico Gico Nacional issued their first outlook for the Pacific hurricane season, expecting a total of 15 named storms, 7 hurricanes, and 3 major hurricanes expected. A month later, the agency revised their outlook to 14 named storms, 7 hurricanes, and 5 major hurricanes, citing the anticipated development of El Niño ±0 for above-average activity, compared to the 1949 to 2013 average of 13.2. On May 22, the Climate Prediction Center announced its prediction of 14 to 20 named storms, 7 to 11 hurricanes, 3 to 6 major hurricanes, and an accumulated cyclone energy within 95 to 160% of the median. It also called for a 50% chance of an above-normal season, a 40% chance of a near-normal season, and a 10% chance of a below-normal season. Similar to the SMN outlook, the basis for the forecast was the expectation of below-average wind shear and above-average sea surface temperatures, both factors associated with El Niño ±0 conditions. Within the Central Pacific Hurricane Center's jurisdiction, 4 to 7 tropical cyclones were expected to form, near or above the average of 4 to 5 tropical cyclones. Seasonal summary. The season's first named storm, Amanda, developed on May 23, shortly after the official start to the Pacific hurricane season on May 15. Based on the 1971-2009 long-term average, the average date for the first named storm is June 10. On May 24, the system intensified into a hurricane, transcending the climatological average date of June 26 for the first hurricane. The next day, Amanda attained major hurricane status, over a month sooner than the average date of July 19. The accumulated cyclone energy index for the season is a 1500 UTC. Augusta 5 is 55.195 units for the East Pacific and 0.565 units for the Central Pacific. Through June 14, the seasonal ACE reached its highest level since 1971, when reliable records began, for so early in the season. Compared to the 1981-2010 average, 2014 was 6 times above normal. By the end of June, the ACE total remained at 230% of the normal value. Storms. Hurricane Amanda. The National Hurricane Center began monitoring an area of disturbed weather south-southwest of the Gulf of Tehuantepec on May 19. Tracking west-northwest in a favorable environment, the disturbance attained sufficient organization to be declared a tropical depression at 2100 UTC on May 22. It intensified into Tropical Storm Amanda by 1500 UTC the following day in conjunction with satellite intensity estimates. By 1500 UTC on May 24, the system intensified into the first hurricane of the season and began a 24-hour period of rapid deepening, in which winds increased from 75 mph to 155 mph. Shortly after peak intensity, increasing wind shear, drier air, and upwelling caused Amanda to begin a weakening trend. However, during the afternoon of May 27, Amanda briefly re-intensified to a Category 3 hurricane as the eye once again became visible on satellite imagery, only to weaken back to a Category 2 hurricane for a second time hours later, roughly 575 mi south-southwest of the southern tip of Baja California. On May 28, Amanda weakened to a tropical storm and a tropical depression the next day. By 2100 UTC, the depression degenerated into a non-convective remnant area of low pressure. Under the anticipation of heavy rains and landslides, weather alerts were issued for Guerrero and Manzanillo. 34 shelters opened in Michoacán while 80 opened in Guerrero. Heavy rains occurred Guerrero, resulting in flooding. a river near Coyuca de Benitez overflowed its banks. 3 trees were brought down and a vehicle in Acapulco was destroyed. Statewide, 1 person was killed when a tree that had fallen on the road resulted in a fatal car wreck. In Colima, minor landslides occurred, resulting in the closure of Federal Highway 200. Much of Michoacán was battered by large waves and heavy rains, resulting in 2 casualties. Several roads were destroyed in Zetacuaro. On May 25, Amanda became the second earliest East Pacific major hurricane on record, behind 2012's Hurricane Bud. Later that day, it also became the strongest May tropical cyclone in the eastern Pacific basin in the satellite era, eclipsing the previous record set by Hurricane Adolph in 2001, which had peak winds of 145 mph. Tropical Storm Boris. The precursor of Tropical Storm Boris developed as an area of disturbed weather, possibly connected with a tropical wave, south of Guatemala in late May. Gradually becoming better organized, the NHC designated the system as a tropical depression on Junio 2, based on a combination of ship observations and satellite intensity estimates. Despite its designation, the disturbance remained generally disorganized, with the presence of multiple and distinct circulation centers. However, additional satellite monitoring indicated that the depression exhibited winds of tropical storm force, and accordingly the NHC upgraded the system to Tropical Storm Boris early on Junio 3. Although initial forecasts suggested the Boris would meander for several days over open waters, the storm quickly tracked northward, bringing it to a landfall near Chiapas, Mexico at around 0600 UTC on Junio 4. Soon thereafter Boris succumbed to interaction with land, and degenerated into a trough of low pressure over the Isthmus of Tehuantepec later that day. Posing a considerable rainfall and mudslide threat to Guatemala, classes were suspended in 9 school districts, impacting 1.25 million pupils. Similarly, some classes were suspended in the Mexican states of Chiapas and Oaxaca. In the former, roughly 16,000 people were evacuated out of hazardous areas. Most of the impacts associated with Boris were due to its developing precursor, whose heavy rainfalls caused 20 mudslides, killing 5 and resulting in extensive property damage. Heavy rainfall in Chiapas caused rivers to overflow their banks, resulting in minor damage. Overall, the effects of Tropical Storm Boris and its precursor killed 6 people across Central America. Hurricane Christina. In early June, the NHC began monitoring a broad area of low pressure within the monsoon trough south of Mexico. Associated convective activity increased and became well organized, leading to the formation of a tropical depression by 2100 UTC on Junio 9. Amid a favorable environment, the depression steadily intensified, becoming Tropical Storm Christina 6 hours later and a Category 1 hurricane early the next day. Over the subsequent 24 hours, the cyclone began a period of rapid deepening, becoming a Category 3 hurricane the earliest second major hurricane on record in the East Pacific by 0900 UTC on Junio 12 and a Category 4 hurricane by 1230 UTC as it developed a well-defined eye surrounded by extremely cold cloud tops. After attaining peak winds of 150 mph, increasing westerly shear and mid-level dry air prompted Christina to begin a weakening trend. The storm weakened to a tropical storm by 1500 UTC on Junio 14 and further to a tropical depression 24 hours later. At 2100 UTC, Christina was declared a post-tropical cyclone after having been devoid of deep convection for a day. Under the anticipation of 12 FT waves, a yellow alert was issued for Colima, Guerrero, Oaxaca, and parts of Jalisco and Michoacán. Along Manzanillo, strong waves resulted in minor flooding that damaged one road. Tropical Storm Douglas. On Junio 23, the NHC began highlighting the potential for a tropical cyclone to develop south of Mexico several days out. A large area of shower and thunderstorm activity developed on Junio 25, leading to the formation of a broad area of low pressure 2 days later. Steered west-northwest by a mid-level ridge to the north, the disturbance steadily organized over warm water and in a low wind shear environment and acquired sufficient organization to be declared a tropical depression by 2100 UTC on June 28. At 0300 UTC on June 30, it was upgraded to Tropical Storm Douglas. Later on June 30, Douglas attained its peak intensity with 45 mph winds, but the NHC noted that this operational estimate could possibly be slightly low. As a result of dry air infiltrating Douglas circulation and Douglas traversing cooler waters, its maximum sustained winds decreased to 40 mph on July 2. The unfavorable conditions slowly but surely took their toll on Douglas, and the storm weakened to a tropical depression during the early morning hours of July 5. At 11 o'clock Eastern Time the same day, Douglas was declared a post-tropical cyclone, as it had lost all of its deep convection and its center of circulation was fully exposed. Tropical Storm Aida, the NHC began monitoring a large area of disorganized showers south of Central America on June 27, as the system tracked generally west-northwestward. Despite unfavorable upper-level winds as a result of its proximity to nearby Tropical Storm Douglas, convection associated with the disturbance steadily increased over the coming days, resulting in the designation of Tropical Storm Aida by 1500 UTC on June 30. Initially, moderate to strong wind shear was expected to decrease in subsequent days, allowing for some intensification of the cyclone. However, this did not occur and Aida began to weaken instead as the low-level center became decoupled from the deep convection. After being devoid of thunderstorms for over 12 hours, the system was declared a post-tropical cyclone by 0900 UTC, on July 2. Tropical Storm Fausto, on July 7, an area of low pressure located about 1,000 nautical miles southwest of the southern tip of Baja California acquired enough organized convection near its center to be declared Tropical Storm Fausto. Soon afterwards, Fausto attained its peak intensity of 40 knots, and it developed a larger, more symmetrical shape with good upper-level outflow. As a result of a low to mid-level ridge to the north of Fausto, the storm moved on a west-northwestward track, and late on July 8, the National Hurricane Center determined that Fausto's center had pulled away from the main area of convection. Fausto continued to weaken, and by 0900 UTC July 9, Fausto was downgraded to a tropical depression. This weakening was believed by the NHC to be at least partly due to dry air entrainment in the mid-levels of the atmosphere. Within the following 6 hours, Fausto decreased in its intensity, and by 1500 UTC, Fausto had degenerated to a remnant trough of low pressure. Tropical Storm Wally, on July 17, the Central Pacific Hurricane Center began issuing advisories on the newly formed Tropical Depression 1C, located about 1,070 miles east-southeast of Honolulu. Within 1 hour, the depression had further intensified. As the CPHC had recently received information from a satellite pass detecting a 35 to 40 kT swath on the west side of the system, it decided to upgrade Tropical Depression 1C to Tropical Storm Wally at 2200 UTC July 17. Wally continued forward in a northwestward direction as it was steered around a mid-level ridge centered to its northeast. While deep convection continued with Wally's overall circulation, the low-level circulation center was on the western edge of a continuously shrinking ball of convection. Based on visible and microwave satellite fixes made after Wally's center was found to be considerably farther north and west than expected, Wally was downgraded to a tropical depression by the CPHC at 2100 UTC July 18. By 0300 UTC July 19, visible satellite imagery showed only a small low-cloud vortex, being the remnants of Wally, as the storm had degenerated into a post-tropical remnant low. Tropical Storm Genevieve, Tropical Depression Genevieve formed on July 25. NHC and JTWC made its final advisories on Genevieve on July 27 and became remnant low. Just after 2 days of being a remnant low, it reorganized to a tropical depression, before dissipating on the next day. Due to favorable conditions, again, the remnants regenerated into a tropical depression for a second time on August 2. It regained tropical storm intensity later that day. Current storm information, as of 5 a.m. HST Augusta 5, Tropical Depression Genevieve is located within 30 nautical miles of 11.1 degree N 171.1 degree W/11.1. Minus 171.1 I, about 1,120 miles southwest of Honolulu, Hawaii and about 400 miles south-southwest of Johnston Island. Maximum sustained winds are 30 knots, with stronger gusts. Minimum central pressure is 1,005 millibars, and the system is moving west-northwest at 12 knots. Genevieve is expected to move out of the basin by early tomorrow. For latest official information see, the CPHC's latest information on Tropical Depression Genevieve. Hurricane Hernan, Tropical Depression 8E formed several hundred miles south-southeast of Baja California Peninsula on July 26. It strengthened into Tropical Storm Hernan later that day. Hurricane Isel, Tropical Storm Isel formed on July 31 about 10:75 mi southwest of the southern tip of Baja California. By 09:00 UTC Augusta 1, Isel had developed deep convection in a central dense overcast, and the storm continued to intensify with only light to moderate wind shear and warm waters conducive for further development. Isel continued to travel on a west-northwestward track as it moved around the subtropical ridge to its north, and by 03:00 UTC Augusta 2, Isel had intensified into a Category 1 hurricane with a well-defined eye and cold cloud tops in a small, dense central overcast. Current storm information, as of 8 a.m. PDT Augusta 5. Hurricane Isel is located within 10 nautical miles of 16.0 degree N 139.5 degree W/16.0. Minus 139.5 I, about 1,055 miles east-southeast of Hilo, Hawaii. Maximum sustained winds are 110 knots, with stronger gusts. Minimum central pressure is 955 millibars, and the system is moving west at 8 knots. Hurricane force winds extend outward up to 35 miles from the center of Isel and tropical storm force winds extend outward up to 115 miles from the center. That day it was declared a Category 4 storm. For latest official information see, the NHC's latest public advisory on Hurricane Isel, the NHC's latest forecast discussion on Hurricane Isel. Tropical Storm Julio, Tropical Depression 10E formed late on August 3. Early on August 4, the depression was upgraded to Tropical Storm Julio. Current storm information, as of 8 a.m. PDT Augusta 5, Tropical Storm Julio is located within 30 nautical miles of 14.0 degree N 124.7 degree W/14.0. Minus 124.7 I, about 1,145 miles west-southwest of the southern tip of Baja California. Maximum sustained winds are 50 knots, with stronger gusts. Minimum central pressure is 1,000 millibars, and the system is moving west at 11 knots. Tropical storm force winds extend outward up to 105 miles from the center of Julio. For latest official information see, the NHC's latest public advisory on Tropical Storm Julio, the NHC's latest forecast discussion on Tropical Storm Julio. Storm names. The following names will be used for named storms that form in the northeastern Pacific Ocean during 2014. Retired names, if any, will be announced by the World Meteorological Organization in the spring of 2015. The names not retired from this list will be used again in the 2020 season. This is the same list used in the 2008 season with the exception of Amanda, which replaced Alma. The name Amanda was used for the first time in 2014. For storms that form in the Central Pacific Hurricane Center's area of responsibility, encompassing the area between 140 degrees west and the international date line, all names are used in a series of 4 rotating lists. The next 4 names slated for use are shown below. Season effects. This is a table of all of the storms that have formed in the 2014 Pacific hurricane season. It includes their duration, names, landfall, denoted in parentheses, damages, and death totals. Deaths in parentheses are additional and indirect, but were still related to that storm. Damage and deaths include totals while the storm was extratropical, a wave, or a low, and all of the damage figures are in 2014 USD. See also: List of Pacific hurricanes, List of Pacific hurricane seasons, 2014 Atlantic hurricane season, 2014 Pacific typhoon season, 2014 North Indian Ocean cyclone season, Southwest Indian Ocean cyclone seasons, 2013 Euro 14, 2014 Euro 15, Australian regions cyclone seasons, 2013 Euro 14, 2014 Euro 15, South Pacific cyclone seasons, 2013 Euro 14, 2014 Euro 15. Footnotes. References. External links: National Hurricane Center website, National Hurricane Center's Eastern Pacific Tropical Weather Outlook, Servicio Meteorológico Nacional website.